This is the last material that we need to cover for the test. Just going to be talking about ratios again. Using indirect measurements. We're going to use ratios to make indirect measurements. We're going to use scale drawings to solve problems. First part we've talked about. Let's see if I can get some of this to show and hide some of the other pieces. Alright, so this is what we're given. We're given that triangle ABC is similar to triangle DEF. And here is triangle ABC, sides 3, 4, and 5. And here is triangle DEF, sides 10, 6, and 8. So now if we're just asked to write a similarity ratio, again, all we're going to do is match up our pieces. So side AB over side DE, AB over DE, side AC over DF, side AC over DF, and side BC over EF, and we'll notice that they all equal to 1 over 2. So my similarity ratio is 1 over 2, and for now we're just going to call that A over B. That'll make more sense here in a little bit. So this part should be reviewed. If you're trying to get the similarity ratio, just match up all your side lengths. You'll see that it's 1 over 2. Okay, now we're going to get the perimeter ratio. So we're going to take the perimeter of triangle ABC, and we're going to put it over the perimeter of triangle DEF. And if I find the perimeter of ABC, if I add up all the sides, that's just equal to 12. If I find the perimeter of triangle DEF, that's just equal to 24. Notice it's also 1 over 2. It's also A over B. Notice the similarity ratio and the perimeter ratio are the same. That will always be true. They are always equal to each other. So once you know the similarity ratio, you already know the perimeter ratio, which is not true of the area ratio. So now let's do area. If I find the area of triangle ABC, remember it's area of a triangle is equal to base times height divided by 2. So I'll do 3 times 4, which is 12. 12 divided by 2 is 6. Now if I do the area of triangle DEF, I'll do 6 times 8, which is 48. 48 divided by 2 is 24. Now what I need to see here is notice when I do 6 over 24, I get 1 over 4, which is the same thing as our similarity and perimeter ratios squared. These two are always going to be equal. Similarity and perimeter are always going to be equal to each other. And once I know those, all I have to do is square it to give me the area ratio. The area ratio is the perimeter ratio squared. 1/2 times 1/2 is 1 over 4. Okay, so here's a problem. It gives us similar figures, just to sort of map it out for us. Similar figures. Notice I can write rectangle ABCD similar to rectangle WXYZ. Okay, let's do the first piece. Ask me for the similarity ratio. All I'm doing is matching up pieces. I'm saying that side AB over WX should be equal to side BC over XY. Again, matching up my pieces. So 21 over 15 should be equal to 14 over 10, and it is, and it's 7 over 5, which we'll call A over B. So we should know by now, that when I do my perimeter ratio, it should also be equal to 7 over 5. When I do it, I'd have the perimeter of rectangle ABCD, add up all the sides, and you'll get 70. Perimeter of rectangle WXYZ, add up all the sides, you'll get 50. And if I take perimeter of rectangle ABCD over perimeter over rectangle WXYZ, I'll get 70 over 50, which is 7 over 5. Notice it's the same. Now, I should be thinking about areas. Area of the rectangle is length times width. Area of rectangle ABCD is 294. Area of rectangle WXYZ is 150. If I take 294 over 150, I can use my calculator to figure out that it's 49 over 25, which does match up. It's equal to my perimeter in similarity ratios squared. Alright, now how do I do a real problem? This is usually how they are on the tests. It gives you your two similar shapes. So here is what I'm told. I'm told that these two triangles are similar to each other. The perimeter of this one is 27. Perimeter of this one is 32, and I'm asked to find the perimeter and the area of this triangle. So first thing I'm going to do is I'm going to write my similarity ratio. I'm going to take this 8 over this 24. 8 over 24 is 1 over 3. That is my similarity ratio. But remember, that has to be the same as my perimeter ratio. Similarity ratio and perimeter ratios are the same. So if this is my similarity ratio, 1 over 3, and the perimeter of my smaller triangle is 27, I can put the 27 on top and my perimeter of the bigger triangle on bottom. Cross multiply and you get x equals 81. Do that same thing we just did to get the area. I already figured out my similarity ratio was 1 over 3. Square that. 1 over 3 times 1 over 3 is 1 over 9. So this is my area ratio. Area ratio 1 over 9. So I have 1 over 9 equals the area of the smaller rectangle over the area of the bigger rectangle, which is x. Cross multiply and you'll get 288 for the area of the bigger triangle. We'll do more of these in class. Just be familiar with this stuff. Dilation, new word. Transformation that changes the size but not the shape of a polygon. Scale factor describes how much the figure is enlarged or reduced. So I had a small shape, multiplied it by some number, and it got bigger. That some number is called my scale factor. Okay, how do we do a problem? Notice I have a small triangle, dilating it to a big triangle. And they are looking for the scale factor. What number did I multiply each of these points by to get my bigger shape? So my new A over here is at 3. My new A is at 3. The bigger A is at 3. That's going to go on top. My original A was right there at 2. So I have 3 over 2. My new B is also at 3. My original B was at 2. 3 over 2. My new C is at 6. My old C was at 4. 6 over 4, 3 over 2. So my scale factor is 3 over 2. Again, we'll do more of these in class also. Just be familiar with it. Last example I got for you. Gives you this shape, and it wants to know, find the coordinates of D, and it wants the scale factor. So let's do this. So my original C was at 9. It's off over here. It went from 9 to 12. So I'm going to put 9 to 12. And my B was at negative 15, and now it went to D. That's what I'm trying to figure out. Where did it go to? So I have 9 is to 12, as negative 15 is to what? Cross multiply, and you get that this D has to be at negative 20. So it was at negative 15, it's now moved to negative 20. And to get my scale factor, I'm going to take this 12 over this 9, and that's going to be equal to 4 over 3. Notice this negative 20 over negative 15 is also 4 over 3. So it's 4 over 3 is my scale factor. We'll do more of these in class.